Okay, can you hear me okay?
Yes, we can.
Terrific. Well, let me welcome all of you to the 165th meeting of the National Advisory Environmental Health Sciences Council. So I'm Rick Wychick, the director of NAEHS and the National Toxicology Program. And the first order of business is to go around and for various members of council and members of senior leadership and others on the webinar today to introduce themselves. So Pat, do you want to take us through the introductions? But Pat, you have to unmute first.
No, I've only been doing this for 2 years. You need to read the Sunshine Act thing. Do you have that in your?
Oh, I don't have it with me right now.
Okay, I'll read it if that's okay.
Just go ahead and read it.
Yeah.
Sorry.
Okay. It says imagine this is Rick's sentence. Pursuant to the government in the Sunshine Act, all aspects of this meeting are open to the public except the review, discussion, and evaluation of grant applications and related information. So I'll say more about that in a minute. All right. So let's do some introductions here. So I'll call your name, start with council members. And then if you just state your name and your title and where you're from, that would be great. So I'm going to start. Brad.
Brad Reset, Washington University School of Medicine.
Thanks, sir. Edith.
Edith Parker, University of Iowa College of Public Health.
Karen.
Hello, Karen Vasquez. I am at the University of Texas at Austin.
Thank you. Katrina.
Hi, I'm Katrina Korfmacher at the University of Rochester Environmental Health Sciences Center, where I direct the Community Engagement Corps.
All right. Lynn.
Hi, I'm Lynn Goldman. I'm at the Milken Institute School of Public Health at the George Washington University.
Thank you. Marla.
Hi, my name is Marla Perez Lugo, and I am a faculty member at the University of Texas, Rio Grande Valley.
All right. Robin.
Robin Tangway at Oregon State University.
Thank you. And Terry.
Hello, everyone. Terry Cavanaugh, University of Washington.
Okay. And Trevor.
Trevor Penning, Perelman School of Medicine, University of Pennsylvania.
And then Andrew Geller.
Hi, I'm Andrew Geller at the United States Environmental Protection Agency, Office of Research and Development.
Thank you. And Bill.
Hello, I'm Bill Sabolis. I'm with the Centers for Disease Control and Prevention and the Agency for Toxic Substances and Disease Registry.
Thank you. And Dr. Holian, are you with us?
Three Holian, University of Montana.
Thank you. Gary Miller.
Gary Miller, Columbia University.
Jenny Ingram.
Yate, good morning. I'm Jenny Ingram from Northern Arizona University.
And Dr. Bourne.
Yeah, hi, I'm Phil Bourne from the School of Data Science at the University of Virginia.
Okay, I would now like to give our senior leadership a chance to introduce themselves. We'll start with you, Rick.
Okay, Rick Wychick, the director of NAEHS and the National Toxicology Program.
And Gwen.
Gwen Coleman, Senior Advisor to the Director, NAEHS.
And I'm sorry, Daryl.
Hi, I'm Daryl Zeldin. I'm the Director of Division of Intramural Research.
And Brian.
Hi, I'm Brian Berridge. I'm the Scientific Director for the Division of the National Toxicology Program and the Associate Director of the National Toxicology Program.
And Jan, are you on?
Yes, I am. I'm Janet Hall, and I'm the Clinical Director of NAEHS.
And Mitch, are you with us?
I am. Hi, I'm Mitch Williams. I'm the Acting Associate Director for Management for NAEHS.
Thank you. And Rick, I'm going to leave you with the last introduction of our senior staff.
Yes. And so actually, John, could I have this first, the slide? So I am very pleased to announce this morning that the new Deputy Director for NAEHS is Dr. Trevor Archer. So Dr. Archer came to NAEHS in the prestigious SBRS program as a nationally and internationally recognized scientist in the field of molecular endocrinology, epigenetics, and chromatin biology. In 2002, he was selected as a chief of the Laboratory of Molecular Carcinogenesis And in 2014, during the reorganization of DIR, Dr. Archer became the chief of the newly created Epigenetics and Stem Cell Biology Laboratory. So he has achieved the distinction of being one of the few NIH distinguished investigators. So congratulations to Trevor and welcome to the leadership team. But I failed to mention that, so in the beginning, actually Dr. Trevor received his PhD degree in biochemistry in 1987 at Queen's University, Kingston, Ontario, in Canada. And in 1991, he was appointed assistant professor in the Department of Obstetrics and Gynecology and in the Department of Biochemistry at the University of Western Ontario in London, Ontario. So Trevor, it's good to have you on the team. And I don't know, do you want to unmute for just a second and just say hello to everyone?
Thank you, Rick. It's a great pleasure to begin this new position. I look forward to working with all of you on the council as we go forward. Thank you.
Perfect. Thanks, Trevor. Okay, Pat, we continue on with other introductions.
No, we're done with introductions, but I didn't know if you wanted to say a few words about our new members.
Actually, I'm just delighted to have the new members on council. So welcome all of you.
All right, thanks. I just noticed that Dr. Hertz-Pachotto has joined us. Did you want to introduce yourself earlier?
Yes, I'm Irva Hertz-Pachotto. I'm the director for the Environmental Health Sciences Center at the University of California in Davis, and I'm an environmental epidemiologist by training, and glad to be here today.
Thank you.
Okay, Pat, you're on mute.
Then I'm going to do it on mute then. Just a couple of housekeeping things. We remind you that we don't have a full break for lunch today. So if you need, we're doing a working lunch, if you need to grab some food, please do that. We have a 15-minute break later on today if you need some time there. This meeting is being webcast, so it's important that you turn off your microphones when you're not speaking. We also ask that you turn off your video when you're not speaking to save on bandwidth to make the meeting run better. As I've mentioned, this is being publicly webcast, and members of the public who may wish to express views regarding any of the items being discussed during the meeting may do so by sending an email to council using the address listed on the council webpage, which is, I'll read it here, national.advisory.council@niehs.nih.gov. You can use that during the meeting or after the meeting, and we'll try to get back to you as quickly as we can. As always, or as in recent time, all voting will be conducted electronic via the electronic council book. The next thing we need to do is have consider our and get approval for our September 2021 meeting minutes. So I would ask that, and also for the November special open session council meeting. So if I can have a motion to approve the minutes from the September council meeting and the November special council meeting, I would appreciate that.
So
I move.
So got a second?
Second.
Any discussion? If not, I will ask the council members that they vote electronically for the approval of these minutes. And Liz, you will let me know when that's happened.
I will.
Okay. While voting is taking place, I just will mention that in your ECB, you should have, in your electronic council book, you'll have a list of the future meeting dates. Our next one will be June's says 7th and 8th, I guess. That will be a virtual meeting. We don't know what will happen in September, but as of now, June's meeting is to be a virtual one.
Still voting. We don't have a quorum yet.
Okay. Is anyone having trouble they'd like to?
Yeah, I'm having a hard time figuring out where this is located. Liz, can you direct me?
It's on the current council tab. Under consideration of meeting minutes.
Quick question, new members that weren't present for that meeting, do we also vote?
Oh, Liz, that's probably not necessary, right? Well, actually the minutes were, I never thought about it. I would say probably don't mess with it. That'd be fine.
Okay.
Good point.
Dr. Penny, could you vote on the November minutes?
I just voted, Liz.
Okay. We have quorum.
Terrific. All right, thank you all very much. And with that, Rick, I will turn it back over to you for your director's report.
Terrific, great, thanks, Pat. And just want to check, can everyone still hear me okay?
Yes, sir.
Okay, terrific. Let's go to the next slide, please. So let me kick things off by talking about some changes in the senior leadership, both at NAEHS and at the NIH. And I've just mentioned that Dr. Archer has assumed the role as the deputy director. I guess his official start date was yesterday. So again, welcome to Trevor Archer. So I also want to take this opportunity before going on and thanking Dr. Gwen Coleman for the outstanding work that she did over the slightly more than 2 years since October of 2019 as the acting deputy director. It was just a pleasure working with her. And I look forward to continuing to work with her as she transitions into this new role as senior advisor to the director in the office of the director here at NIEHS. So next slide, please. So I also want to take a moment to acknowledge in a public setting, my appreciation, and I suspect that I'm speaking for all of us at NIEHS and the environmental health sciences community, that we all appreciate the leadership that Dr. Francis Collins brought to the NIH. Because all of you know, Francis retired at the end of December after serving 12 years as the director of the NIH. He was the only NIH director to serve more than one administration. And I don't have time to list all of his truly noteworthy accomplishments as director, but I do want to highlight that he developed a close bipartisan working relationship with Congress. And I've seen him in action with Congress. His ability to communicate our work to members of Congress was really quite remarkable. And quite noteworthy was the fact that under his leadership, the NIH budget grew 40%. So we've all benefited tremendously from his leadership on this. So additionally, since I've been very close to the NIH-wide efforts to address the challenges associated with the pandemic, the COVID-19, I was able to experience firsthand his, again, just remarkable leadership to bring together the public and the private sectors to work collaboratively to develop therapeutics and testing strategies for COVID-19. So we'll miss his leadership, although I know that the director job is pretty all-consuming. It's pretty tough. So I predict that Francis is looking forward to getting back to working as a scientist within his intramural research program at NHGRI. So again, thank you, Francis, for your leadership. Next slide. So going to the next slide, please. Okay, here we are. So while we will miss Dr. Collins, I'm reassured that the leadership of the NIH has been left in the capable hands of Dr. Tayback, who, as you, I think, all know, Larry was the deputy director during the tenure of Dr. Collins. So Larry has been a pleasure to work with, and I know that he will keep the NIH sailing on an even keel. So also Dr. Tara Schwetz has stepped in as the acting deputy director of the NIH. I've worked closely with Tara over the past couple of years as the co-chair of the Executive Committee for the Rapid Acceleration of COVID-19 Diagnostics. She is really smart, just exceptionally responsive to our needs at NIEHS and is providing remarkable interim leadership as the acting deputy director. So while we await the announcement of who the next NIH director will be, which will come from the president and the White House and will require confirmation from the Senate, I know that we are in good hands with the leaderships from Drs. Tayback and Dr. Schwetz. Next slide, please. So before I go on to discuss the budget, there's another very important change in leadership in Bethesda that I want to make sure that you're all aware of. So after 28 years as the Deputy Director of Intramural Research at the NIH, Dr. Michael Gottisman has decided that he will step down from his administrative position and, like Dr. Collins, will return to his laboratory at the NCI to study the mechanisms of chemotherapy resistance in cancer. So as Deputy Director for the IRP, the Intramural Research Program, he coordinates activities and facilitates cooperation amongst the intramural programs across 24 ICs, again, across the NIH. So Michael has been just terrific to work with. And I believe it's noteworthy that Dr. Collins called Dr. Gottisman among the most caring and accomplished scientists and scientific leaders that I have ever met. So the search for Dr. Gottisman's successor is currently underway. So stay tuned and we should be hearing something about that shortly. Next slide. So let me move on to discuss the FY22 budget. So I went over the president's budget at our meeting last June. But since then, as I'm sure you're all aware, the fiscal year 2022 appropriations process has been underway in Congress. So in July, the House passed the FY22 appropriations minibus, which is a bill that includes all of the funding measures for NIEHS. It has NIEHS at a mark of about $942 million, which represents an increase of about $127 million from the FY21 enacted level. The report language allocates an increase of $100 million for climate change and health research for the NIEHS and has additional language specific to harmful algal blooms and Parkinson's disease. So this amount passed in the House is above the president's FY22 request of about $937. So the House FY22 Interior and Environment Bill has been approved at about $83.5 million. And this is the funding for the NIEHS Superfund related programs. And I'm pleased to say that this is $2 million above the FY21 enacted level. The report language supports the worker training program's effort in responding to pandemics and disasters, as well as the NIEHS Superfund research program's ongoing work with risk communications. So as you can see on this chart, this allocation is at about the same level as the president's in FY22, the president's FY22 budget request. And finally, the House FY22 Energy and Water Development Bill included report language to transfer $10 million from the Department of Energy to the NIEHS Worker Training Program, which is the same as it has been for the past several years. So when you add it all up, the House is recommending a budget that puts the NIEHS allocation at about $1,035.5 million, which is a substantial increase over FY21. So for the NIH as a whole, the House bill provides a total of $49.6 billion, which would be an increase of $6.7 billion above the FY21 enacted level. Additionally, the bill includes $3 billion to establish the Advanced Research Projects Agency for Health, or something we've come to call the ARPA-H. And as I mentioned last time, this is meant to be a new program in the NIH to accelerate the pace of scientific developments for biomedical research. The ARPA-H program is modeled on the DARPA program at the Department of Defense, and it's all about high risk, high reward results. So this is down from the $6.5 billion that was in the president's budget, although we'll have to wait to see what the final congressional budget allocates for this new program. So the Senate bill provides a total of $48.1 billion for the NIH, which is an increase of $5.2 billion over the FY21 enacted level. The bill also includes an increase of about $5 billion for existing NIH institutes and centers like NIEHS. So we don't get the whole $5 billion, but we'll get a part of that. So additionally, the bill includes about $2.4 billion to establish the ARPA-H. So overall, I'd say that the budget is encouraging at this point, but I need to remind everyone, and I always remind myself, that this is not final until Congress passes the budget for FY22. And so, as I mentioned at our last council meeting, the good news is that there is strong bipartisan support for the NIH in Congress, and for the president's budget, the Senate and the House, we're all looking for a pretty significant increase for NIEHS. Now, again, Congress needs to pass another continuing resolution of some or all of the 12 FY22 appropriations bills, and they need to do this by midnight on February 18th in order to keep the government running. So we'll stay tuned, and we've got our fingers crossed that we'll actually get a budget. Next slide. So one important job that we all have is to make sure that members of Congress are aware of the important research that we are conducting at NIEHS and that we're conducting in the National Toxicology Program. So along these lines, we have had 3 different congressional briefings in the past few months. The first was on November 30th with the majority and minority staff on the House Science, Space, and Technology Committee. So Dr. Berridge was joined by Drs. Scott Maston, Wolf, Weiss, Henry, and Kim Gray. And together they discussed our research and development efforts on PFAS. So they also discussed details in the formation of the new Interagency Joint Committee for the Environment. So this is a new subcommittee that's just taking off the ground, and there were questions that they were asked about how do we differentiate between the different PFAS compounds. And we know that there are thousands of them, and what are the health effects associated with these different individual compounds. So they were also asked whether Congress could help by encouraging more interagency collaborations, calling for research in areas that have been overlooked, or by encouraging a focus on STEM workforce issues. So our second briefing was on January 18th. That's a briefing that I participated in. In fact, I met with Miss Janet Erickson, who is the new House Interior and Environment Majority Staffer. So I briefed her on our Superfund related programs. And this was primarily kind of get to know the program briefing since she's new. And I was encouraged at how interested she was in the Superfund programs. So we want to make sure that Congress continues to understand the importance of the work of the Superfund research program and the worker training program. So I was really encouraged again by her engagement and the questions that she asked. So our third briefing was on February 9th. So I met with the House and Senate majority and minority staff of the Labor HHS Appropriations Committees. And joining me for that briefing were other IC directors, including Drs. Tromberg, Peristables, and Gibbons. So I presented details on the RAD program, which stands for Rapid Acceleration of Diagnostics for COVID-19, RADICAL. And these programs are all about innovative, non-traditional, and radical approaches for COVID-19 testing. So this is what I do my weekends and evenings when I'm not the director of NIEHS. So the projects in RAD range from wastewater testing for the SARS-CoV-2 virus, the development of breath analyzer tests, really interesting technologies. There are touchpad testing approaches for testing for SARS-CoV-2. And these also extend all the way to the innovative use of next-gen sequencing for multiplex testing of individuals for COVID-19, which is actually the only intramural program that's funded by RAD. And that's to an investigator, Doug Bell's lab with his group and at NIEHS. So they're doing some really interesting and terrific work. Next slide. So on the topic of PFAS, there's a lot of interest in PFAS. So I also want to report that 2 of our NIEHS grantees, Dr. Elsie Sunderland, and she's at Harvard, and Dr. Peter Jaffe from Princeton, were witnesses for a hearing in the House Science, Space, and Technology Committee on December 7th. So the hearing was all about forever chemicals, research and development for addressing the PFAS problem. So both Drs. Sunderland and Jaffe described the current state of PFAS substances, and they also described where they felt future actions should be focused. And as we all know, there are many challenges with PFAS, not the least of which is that there are thousands of different chemical species, and that these compounds are highly persistent within the environment. And with the number of contaminated sites across the United States, many of which were contaminated from the use of the AFFF fire suppressing foams, there's a lot of concern in Congress. So we're there to answer any and all questions that they may have. Next slide. So let me move on now to discuss some of the science advances that have happened over the past several months. The first science advance is from the Zeldin Laboratory, from our scientific director, DIR. So this is work that was published recently in the Journal of Clinical Investigation. So the title of this work is SEH promotes macrophage phagocytosis and lung clearance of Staphylococcus pneumoniae. And as a little background, alveolar macrophages are the key cells involved in orchestrating the innate immune response to bacterial infection in the lungs. So Zeldin and his colleagues were interested in studying the molecular mechanisms associated with the bacterial phagocytosis and inflammatory signaling by macrophages. So they previously determined that oxygenation of arachidonic acid forms molecules, and they're called, I'll just call them EETs. And these exhibit potent inflammatory and anti-inflammatory properties. So the EETs are converted to less active molecules called DHETs, and they're converted to DHETs by an enzyme called SEH, which is and SEH is encoded by a gene called EPHX2. So in this study, they were interested in evaluating how EETs and how the protein SEH can impact the clearance of S. pneumoniae. So for their experiments, they used EPHX2 knockout mice for their experiments. And these mice actually show an increased level of EETs. And what they found is that EPHX2 knockout mice had an impaired innate immune response to gram-positive bacteria like S. pneumoniae. And specifically, it appears that the elevated EETs in the EPHX2 knockout mice suppress the induction of some key receptors on the macrophage, and this results in impaired inflammatory signaling. So therefore, as the title says, SEH, which normally functions to decrease EETs, plays a critical role in promoting macrophage phagocytosis. So let's go on to the next slide. So this gives you a sense of the basic molecular mechanistic work that happens within our intramural research division of DIR. So the next slide is a science advance from the division of the National Toxicology Program. So as a little background, the development of harmonized and standardized terminologies, the terminologies, the vocabularies, and ontologies for environmental data will be absolutely critical if we can ever expect to contribute environmental exposure data in a meaningful way for studying the etiology of human disease. So this manuscript describes the efforts that are being made to create a community of practice that will function to exchange information and expertise, will also serve as a communication hub for identifying and prioritizing activities, and will function as a collaboration platform for the development and adoption of semantic solutions. So I'm personally very excited about this. I suspect Phil Bourne is probably pretty excited about it as well. And I believe that this is, it's long overdue. So thanks to Stephanie Holmgren, Charles Schmidt, and their colleagues in the division of the National Toxicology Program, as well as their colleagues across the environmental health sciences community for promoting this very important initiative. Next slide, please. So finally, okay, so hold on, I'm sorry. I'm reading from my notes here in just a minute here. So this is the DNT Science Advance. Let's go back a slide. So let me cover the DERT Science Advance. So I want to highlight this recent impact paper that came out from the extramural community. So this is co-authored by a group of investigators studying the exposome, including Gary Miller. And it describes a new methodology that involves a single-step express liquid extraction called XLE, which is this liquid extraction is coupled with gas chromatography and high-resolution mass spectrometry analysis. So in this paper, they demonstrate that this workflow supports the quantitation of environmental chemicals in 200 microliters of human plasma and in small amounts, less than 100 milligrams of lung and thyroid tissue, as well as the analysis of stool. So your method also provides high resolution, high sensitivity and cell activity for exposome epidemiology of mass spectral features without a priori knowledge of chemical identity. So they also demonstrate a computational workflow that enables on-targeted analysis of identified and unidentified environmental chemicals. So they claim that the simplicity of the method will likely facilitate harmonization of environmental biomonitoring and will enable population-level human exposome research with limited sample volume. So I think this is very exciting, and this may be the technology breakthrough that we all need to promote exposomics research across the globe. So congratulations to Gary and his colleagues for some work that was very well done. Next slide. Okay, let me go on here. I've got way too many screens in front of me. So let's go to the next slide. Okay, here we are. So we're back to in sync with my notes and my other screen here. So I also want to point out the 2021 papers of the year. And these are papers that were featured in the January 2022 issue of the Environmental Factor. So these are 35 of the best papers out of the almost 4,000 papers that were published by NAEHS researchers and grantees. So the publications cover a broad range of topics from metals and e-cigarettes to DNA repair. So the complete list of the publications can be found on the Environmental Factor. And I encourage you to take a look. Some really interesting work that's being featured here. So next slide. So let me move on to update you on the work that we are doing on the topic of climate change and health. So hopefully you all recall that we had a special session of council last November 29th, and there was unanimous approval for the new NIH-wide initiative on climate change and health. So just to refresh your memories, this initiative has a set of ambitious goals to reduce health threats of climate change and to do this across the lifespan. So we also hope that this initiative will build resilience in individuals and communities. And as we explained last November, we are doing this with a focus on those at highest risk. So there are 4 specific objectives of this initiative. The first is to identify risks and to optimize benefits from mitigating or adapting to climate change. The second is to develop the research infrastructure and workforce across a full spectrum of biomedical disciplines. The third is to develop and leverage the necessary partnerships with other scientific and social disciplines that will be necessary to achieve the results we're looking for. And the fourth objective is to innovate across the research translation continuum. And this will help to ensure that the results that we produce as a part of this initiative are credible, accessible, and actionable. So next slide, please. So after the concept clearance, Drs. Coleman and Aubrey Miller and Josh Rosenthal continued their work with the executive committee, the steering committee, and the working group to really go in and start implementing on this new program. So since then, many things have happened. The executive committee felt that it was critically important that NIAID have a direct role in planning next steps on this initiative. So therefore, we actually invited Dr. Fauci to be on the executive committee, but as we expected, he's got a number of other things going on in his life at the moment. So he graciously declined, but instead agreed to have Dr. Lee Hall represent NIAID on the steering committee, which is good. Additionally, there were several new subcommittees that were set up, including the Progress Evaluation and Measures Subcommittee, which will be developing long-term evaluation metrics and plans. The Review Team Subcommittee, which will be it's all about discussing details of the review process. And this includes the Center for Scientific Review and multiple different ICs. The FOA Writing Team Subcommittee, which is working hard to write the funding announcements and the NOCs that the program hopes to release once we get our budget. And the Global Research and Partnership Subcommittee, which is coordinating with partners to provide a global lens to the climate change and health program. Then the NIH-wide group held a webinar on February 9th. It was hosted by NIMHD. It was featured Robert Bullard from Texas Southern University. Many of us know him. The webinar was titled, "Why Climate Change is a Health Threat." He discussed how people of color and low-income households have contributed the least to the climate crisis, but they are the most greatly affected by it. So the next webinar is part of this series is scheduled for February 22nd. NHLBI is hosting Jonathan Samet and Dr. Tammy Bond from the University of Colorado School of Public Health. The webinar is titled Climate Change, Air Pollution, and Health. So what lies ahead? So registration is required for the event, but I hope you will join us. These have been just incredibly insightful, all of these lectures. Next slide, please. Whoops, so actually go back one slide. There's one bullet point I missed here. So the last bullet point here is I'm also happy to report that the NIH-wide strategic framework that you heard about on November 29th, it has been finalized. So we have now created a website at www.nih.gov/climate and health. So where you can find the strategic framework along with other materials relating to progress on the climate change and health initiative. So I encourage you to take a look. And you can see the URL just below the picture on the right-hand side of the slide. Next slide. So you'll recall that the working group created what's called the centerpiece diagram. And this was meant to illustrate the components of the strategic framework. So as we mentioned last November, the framework was developed with input from the responses to the RFI, where we got over 180 different substantive input from the global environmental health sciences community. It also included a portfolio analysis input from all working group members at a strategic whiteboarding session that happened late last September. And the framework also included a consideration of the landscape analysis that was conducted by the working group. So the centerpiece diagram illustrates the framework, and it's based on those four different major elements right at the center, which include health effects research, health equity, training and capacity building, and intervention science. So at the center is a focus on transdisciplinary transformative research. That's what's going to happen. And the work will be conducted with global cross-sector interagency and community partnerships with a blue ring around the center elements. And the cogs on the circumference are meant to illustrate specific types of science that will need to be conducted to support the framework. So as you can see, the research areas are truly multidisciplinary in nature. They range from basic, mechanistic research to behavioral social science research, epidemiology experiments and predictive modeling to adaptation research. So again, I encourage you to take a look at the new website if you're interested in learning more of the details and study the strategic framework. It's a very interesting document. Next slide. And finally, on the topic of climate change and health, I just want to point out that members of the steering committee, the members of the working group for climate change and health, as well as staff from across NIEHS have been actively participating in many different climate change and health related discussions and integration of the work that we're doing with external committees. An example would be Burroughs Wellcome Fund, the National Academies Workshop, which was a National Academies workshop group that happened last November. There are a number of other partnerships that I'm showing on the slide, and in the interest of time, I'm not going to go through all of them, but the idea here is that the members of the working group and the steering committee, they are working to get the information that we're doing at the NIH out, sharing this information with other parts of the federal government and other organizations involved in climate change and health. And they're doing this to ensure that the various efforts across the federal government and the global community are well coordinated. So thanks to the members of the committees for spending that extra time to reach out. Next slide. So as hopefully all of you know, I've been working hard to integrate studies on the environment and environmental exposures into the research activities at our sister ICs across the NIH. And as a follow-up on the themes and topics from the 2020 NASEM workshop on environmental neuroscience, advancing the understanding of how chemical exposures impact brain health and disease, I'm pleased to report that an NIH Environmental Neuroscience Working Group has been established under the leadership of Dr. Cindy Lawler and DERT and Dr. David Jett at NINDS. The purpose of this group is to foster more collaborative research amongst neuroscientists and environmental health scientists, and to do this across the NIH. This is an active group with representatives from 9 institutes, centers, and offices from across the NIH. And there's needless to say, strong representation from our colleagues at NAEHS, especially in the extramural research division. So one of the first activities of this group was to prepare a request for information, and this will be coming out soon. So the RFI will be seeking input on opportunities and challenges for interdisciplinary and collaborative research. And the focus will be on bridging neuroscience and environmental health science. So ultimately, we hope that the collaborations between environmental health scientists and neuroscientists will help to advance our fundamental understanding of the contribution of environmental toxins to nervous system function and neurological disease. So NIH is seeking input from a broad range of stakeholders, including clinicians, patient advocacy groups, individuals and families affected by neurological conditions, as well as neuroscientists, toxicologists, and other members of the environmental health sciences community. So I just want to single out Drs. Lawler and Jett and congratulate them on taking on, well, thank them for taking on these important leadership roles and for catalyzing these NIH-wide collaborative activities. So next slide, please. So I'm also very happy to report that after several delays, I think it was partly due to the transition to the Biden administration and new people and new leadership at HHS. The HHS has released the 15th report on carcinogens, and this happened on December 21st. So thanks to Mary Wolf for all of her careful efforts to guide this through the process. And I think as all of you know, the report on carcinogen is a congressionally mandated, it's a science-based public health document that the National Toxicology Program prepares for the Secretary of HHS. The cumulative report now includes 256 substances that are known or are reasonably anticipated to cause cancer in humans. Publication of the ROC represents an important government activity towards improving public health. So the 15th ROC contains 8 new substances. The first of these is Helicobacter pylori, which I think many of us know it's known to be a human carcinogen. The bacterium colonizes the stomach and causes gastritis and peptic ulcer. And it's clear that H. pylori causes stomach cancer in humans. So it's added to the ROC. The second substance reported in the ROC is antimony trioxide. So this compound is primarily used as a component of flame retardants in plastics, in textiles, and in other consumer products. So the highest exposure occurs amongst workers who produce the substance or use it to make flame retardants. So studies have found lung and other tumors in rodents exposed to antimony trioxide. And additionally, there are 6 haloacetic acids, abbreviated HAAs, and these were all part of the 15th ROC. The HHAs are found as water disinfection byproducts, and they include bromochloroacetic acid, bromodichloroacetic acid, chlorodibromoacetic acid, dibromoacetic acid, dichloroacetic acid, and tribromoacetic acid. So these HHAs are formed during the disinfection of water from the reaction between chlorine-based disinfection agents and organic material in the source water. So approximately 250 million US residents use community water systems and are potentially exposed to HHAs in disinfected water. So improvements in disinfection technology can reduce the level of HAA exposure in drinking water. HHAs also are known to cause mesothelioma, liver, and other tumors in rodent studies. So next slide, please. So I also want to take this just a second here to illustrate the new ROC Dashboard, which is really cool. It provides an interactive visualization and interrogation of the listed substances, their uses and associated cancers. So you can search by substance type or by human cancer type. So this slide gives you a better sense of the wide variety of compounds that comprise the ROC. I encourage you to take a look and play around with it. The new format provides really a robust means to explore the vast amount of data associated with the 256 compounds in the ROC. Next slide. So I also want to provide you with a summary of the 2021 NIH Rural Health Day. It was the Rural Health Day seminar, which NIEHS co-sponsored with NIMHD, the National Institute of Aging, and NIEID. So this seminar followed from the NIH Unite initiative, to end structural racism by highlighting the role of structural level determinants of health, which include exposures that lead to or exacerbate health disparities, rural health disparities. The seminar celebrated a collective awareness across the NIH for the need for research that we need to partner with rural communities to conduct. So our scientific plan emphasizes our commitment to environmental health disparities and environmental justice. Lindsay Martin moderated a discussion with the several distinguished panelists who are shown on this slide. In the interest of time, I'm not going to go through all of them individually, but it is available in the notes for the meeting. Next slide. So on the topic of health disparities, I also want to bring to your awareness a full-day workshop that NIEHS sponsored last December entitled Addressing Racism as a Public Health Issue Through the Lens of Environmental Health Disparities and Environmental Justice, From Problems to Solutions. The workshop was organized by the NIEHS Environmental Health Disparities, Environmental Justice Cross-Divisional Faculty, which is co-chaired by Darlene Dixon and Robin Arnett, shown here on the slide. So remarkably, there are over 700 individuals who attended the workshop. That's, I guess, one of the advantages going virtual. And the goals of the workshop were to raise awareness of systemic racism in America and how it contributes to environmental health disparities and to environmental justice issues. It also helped to inform the NIEHS community of current environmental health disparity research and outreach activities in environmental justice. And finally, it was also a means to engage regional and local community leaders that are involved in environmental justice advocacy networks and to discuss with them best practices for community engagement. The local community leaders presented us with the challenges that they are encountering in their communities, and they want action. So many are living in Superfund sites right in our backyard, and they want them cleaned up. So there were plenty of opportunities to discuss a variety of topics that range from a history of environmental racism, environmental justice issues impacting people of color in North Carolina, and it's not just North Carolina, across the entire United States. And they also discussed what NIEHS should be doing and could be doing to help us build successful and authentic community partnerships to address local environmental health concerns. I mean, examples of this are shown on the slide here in the lower right-hand corner, addressing mold contamination in our public schools, and to address some of the environmental exposures associated with the waste lagoons at hog farms in Eastern North Carolina. So I'll be meeting with these community leaders as a follow-up. Before I do that, I'm asking the working group to help craft solutions so we can bring back to these community leaders specific things that we feel that NIEHS can be doing to help to address their concerns. So stay tuned for the next workshop, which is all about environmental impacts on women's health disparities and reproductive health. And this is scheduled to be held virtually on April 27th and 28th. Next slide, please. So in my last presentation, I talked about the work of the Unite committees at the NIH. And one specific recommendation that came from one specific recommendation that came from the I committee of Unite was that each IC needs to develop a REAP plan, which stands for Racial and Ethnic Equity Plan. So Dr. Archer, our new deputy director, who's also the co-chair of the I committee, is working on developing this plan for NIEHS. So we expect that our plan will specifically apply the racial and ethnic equity lens called REAL, this lens framework, and we will apply this to our workforce, to our structures, and to our systems. And the plan will also describe how we intend to identify and dismantle any racial and ethnic disparities in the workforce at NIEHS. The REAP will also define specific actions that we can take at NIEHS to enhance the diversity of our workforce. So we have until April to establish the plan, which will then be reviewed in April and May, and then we will be implementing on this plan once it's approved. So as director of NIEHS, together with the commitment of all of the senior leadership here at the Institute, we're again committed to developing and then implementing on this plan. And to facilitate this, we've committed to a plan that's being developed by Dr. Archer to hire a chief diversity officer and to staff up that office within the ODD, the Office of Deputy Director, and to staff it up with change advocates who will receive training and other support to implement on the REAP plan. So Dr. Archer and I will certainly keep you posted as to future council meetings to brief you on the details of this NAEHS plan, and to hopefully keep you, well, we'll keep you posted of the progress that we're making as we implement on the plan. So next slide, please. So as part of our efforts to develop the REAP, NAEHS has hired Small World Solutions, a contractor, to help us gather data about the workforce at the Institute. So the contractors developed the Workforce Cultural Equity Survey, and this was deployed to our staff last fall. So there were 341 NAEHS employees who participated in the survey. And based on the results in the survey, we are planning a series of focus groups dedicated to equity and fairness, integration of differences and openness, cooperation, supportiveness, empowerment, belonging, and diversity. So we're hoping that these data gathering exercises will provide us with the information that we need to create and then implement on the REAP. Next slide. So I want to finish up here with just a number of staff updates and some awards by members of our staff and members of our grantee community. And I want to start off by updating you on the fact that we have hired Dr. Dandre Kabel, who is the new chief of our comparative medicine branch. So he succeeds Kathy Labor, who retired at the end of 2021. So before joining NAEHS, Dr. Kabel directed the Animal Resources Corps and was an attending veterinarian at the National Children's Hospital in Columbus, Ohio. So welcome, Dr. Kabel. And thanks very much to Dr. Labor Laird. So Kathy, it's just been a real pleasure working with you. You've done a lot, just an amazing job providing leadership for the branch. And I have to announce publicly to everyone here at today's meeting that under your leadership, NAEHS recently received an exemplary rating with no suggestions for improvement after the recent ALAC inspection. So I've been at several outstanding organizations, including the Jackson Laboratory, and never before have I heard of any organization achieving this level of success and such high marks from ALAC. So thanks for your years of service to NAEHS, Kathy. Next slide. And now that Dr. Archer has been selected as the Deputy Director of NAEHS, I'm also pleased to announce that Dr. Paul Wade will be stepping in to serve as the Acting Chief of the Epigenetics and Stem Cell Biology branch. So Paul is a terrific scientist and a wonderful person to work with. I'm confident that he will bring strong and outstanding leadership to the branch. So also in the Division of Intramural Research, I'm pleased to announce that Dr. Carlos, he goes by Charlie Guardia, has joined our intramural research faculty last December, and he joined as a Stadman tenure track investigator. So he will be conducting his work in the Reproductive and Developmental Biology Laboratory. He was also selected for the NIH Distinguished Scholars Program, which aims to build a more inclusive community within the NIH Intramural Research Program. A selection for this program is highly competitive, and this is a recognition of his outstanding scientific accomplishments. Again, both in science as well as in his efforts to promote diversity and inclusion. So welcome, Charlie, to the NIEHS. Next slide. Actually, in the interest of time, I'm going to skip over the slide here. So I also want to announce that Dr. Ellison, and the material for this is in the written reports. So I'm sorry to skip over, but I'm just looking at the clock. So I also want to just announce that Dr. Ellison, who served as the acting director of the ERT, he has returned to his position of reference at the National Cancer Institute, and he did this at the end of December. So Dr. Maston will be saying more about this in his presentation, I think. But I just wanted to say that we thoroughly enjoyed having Gary with us. So Gary, I don't know if you're listening in, but if you are, thank you for all of the hard work that you did with us from January through December of 2021. So next slide, please. So I also want to announce, in case you haven't heard, that Dr. Chris Weiss, who is a senior advisor and toxicology liaison in the office of the director here at NIEHS, Chris retired in December after 11 years with us at NAEHS and over 32 years of federal service. So he played a key role for NAEHS and the NTP on national and international committees, task force, and ad hoc working groups. So thank you, Chris. I don't know if you're on the session or not, but thank you and congratulations on your retirement. Next slide. So I also want to call to your attention a couple of recruitments that are currently underway. So we are looking for a new executive officer. So those of you not in government, what this means is that we're effectively looking for a chief operating officer for NAEHS. The search committee has interviewed a number of candidates, and we hope to have this position filled within the next several months. So stay tuned. Hopefully at the next time that we meet, I'll be able to announce the new executive officer. Additionally, we are currently in the process of recruiting a new director of the Division of Extramural Research and Training, DERT. So the search committee has been constituted, and you should be seeing the vacancy announcement coming out soon. So please let us know if you or others that you think may be interested in the position, let us know, and we'll have the search committee contact them. So let me also take this opportunity to thank Pat Maston for his willingness to step back in and to provide the interim leadership for DERT. Pat, you're doing a great job. Again, thank you. Next slide. I also want to announce that our former director, NAEHS Director Ken Olden, was recently awarded the Health and Environmental Sciences Institute's Innovation Prize. So this prize recognizes exceptional scientists who have helped improve health equity and reduce health disparities. Ken, just congratulations. I can't imagine someone who is more deserving of this award. Next slide, please. And I also want to acknowledge Dr. Coleman, who received the inaugural Margot Simon Golden Distinguished Service Award from the Massachusetts Breast Cancer Coalition. So this award is presented annually to an individual who best exemplifies dedication to preventing environmental causes of cancer. So congratulations, Gwen, very well deserved. Next slide. So it's also noteworthy that Dr. Benedict Anchang, who is a Stadman investigator in our Intramural Research Division, he recently received the Chan Zuckerberg Initiative Award. So this award includes nearly $820,000 to support research that is focused on shedding light on gene expression patterns during pregnancy, and to do this in a way that could potentially reveal how environmental and social factors influence maternal health. So congratulations, Benedict. Could I have the next slide? So I also want to acknowledge someone who many of us know, Barbara Shane, who retired from the Division of the National Toxicology Program several years ago. Barbara received the 2022 Genetics and Environmental Mutagenesis Society Lifetime Achievement Awards. And congratulations, Barbara. Next slide. And I also want to announce that many of you in the environmental health sciences community know John Baldus. John served as the public health advisor for us here at NIEHS since 2009. He was also the lead scientist at the NIH for many years, advocating for climate change and health programs. So he was recently recruited to serve as the director of the newly established Office of Climate Change and Health Equity at HHS. Additionally, and most notably, I want to point out, if you haven't heard, he was elected to the National Academy of Medicine on October 18th. So congratulations, John. Next slide. I also want to report that our NIEHS grantee, Carla Chief from the University of Arizona, has been named director of the school's new Indigenous Resilience Center. Chief and her colleagues will collaborate with tribal leaders and governments to design. So they're going to design community-driven solutions that address adverse effects of environmental challenges among Indigenous groups. So congratulations, Dr. Chief. Next slide, please. So I'm also very pleased to announce that Molly Frazier was selected as the 24th recipient of the Karen Wetterham Memorial Award. So as I think many of you know, this is an award that is bestowed annually by the Superfund Research Program. Molly was recognized for her work to develop inexpensive and reusable sorbent materials to clean up drinking water contaminated with PFAS. So congratulations, Molly. Next slide, please. And I want to make sure that you're all aware of a number of SOT awards. So first of all, Linda Bernbaum former director of NAEHS and the NTP, has been awarded the 2022 Society of Toxicology Merit Award. And this was in recognition for her distinguished career as a federal scientist and her outstanding contributions to the fields of toxicology and risk assessment. Also, Dr. Lynn Goldman on our council received the honorary membership, which recognizes non-members who embody outstanding and sustained achievements in the field of toxicology and or allied disciplines. So additionally, Thomas Galarte received the 2022 SOT Translational Impact Award. Rakesh Nagarkati received the Distinguished Toxicology Scholar Award. John Weiss was awarded the Toxicologist Mentoring Award, and Christine Willett was awarded the Undergraduate Educator Award. So congratulations to Linda and to Lynn and to all of the NAEHS grantees for their SOT awards. So next slide, coming to the end here. So as you might expect from the NIH's Environmental Health Sciences Institute, we have been working closely with the NIH Office of Research Facilities to make our 40-year-old campus more energy efficient. And in fact, it was in fiscal year 21 under the leadership of Carrie Hartung and Paul Johnson, shown here in the lower right-hand corner. And this also included a big impact from our former executive officer, Chris Long. So what we did was we intensified our efforts through, it's called the Renewable Resilient NIHS Initiative. So with help from the NIHS was powered by 100% renewable energy using renewable energy certificates, which are these certificates help to offset our campus facility energy purchases. So additionally, we are pursuing more energy saving and on-site generation opportunities to reduce our future need for these certificates. And we're doing this by partnering with Duke Energy to identify and fund new energy saving measures through utility energy savings contracts. So next and last slide. And I want to end by thanking retiring members of council. So normally this would be my opportunity to get up, shake your hand, give you a hug, whatever, and present you with a certificate. We'll send the certificates by mail. But Katrina and Edith, Brad, Robin, and Robert, I know Robert's not with us today. Unfortunately, his mother passed away, as many of you may have heard. But it's just been great working with you, and thank you for the time you spent with us. It's been just great having you on council. So with that, I will, if you can stop sharing the next slide. Yeah, thank you. And if you can stop sharing the slides, let's open it to any and all questions that you may have. And I'm gonna close down some of the windows on my big screen here. Okay, thanks. Okay, any questions? Can you still hear me okay? I hope.
Yes.
Lynn, how are you? Lynn, go ahead.
Yes, I have a question, Rick. Well, first, just to thank you for that presentation. It was incredibly comprehensive and informative, and it's always wonderful to see how much progress that the NIEHS is making over time with so many issues. I wanted to specifically ask you about a new initiative that we're hearing about in the federal government that it's not really new, but it's being kind of regenerated, I guess, and that's the Cancer Moonshot. And if there's anything that we can do, I guess, in the environmental health community to help to direct at least some fraction of that effort toward preventable causes of cancer, including environmental causes. You showed us the report on carcinogen, and that's chock full of known, human carcinogens. But we also know that, what we eat, our physical activity, smoking, alcohol, there's so many preventable causes. Probably about half of cancer is preventable, and we could really cut the incidence and mortality down if we could get the public health side of it right. And so, we're out here wanting to advocate for that and wanting to do anything that we can do, to help you as well as the NCI with being able to at least direct some of the focus in that direction. Thank you.
Well, Lynn, I'm glad you asked that question because I have been engaging, I think, in that scientific statesmanship. And one target of my my efforts has been Ned Sharpless. And so Ned and I have had many, several discussions. And Ned doesn't need to be convinced that there are very important environmental contributions to the development of cancer. So we are engaged in discussions right now to really figure out how we can be integrating the environmental health sciences community into the work that happens at the NCI as part of this, well, as part of the general cancer biology program, but certainly bringing environmental exposures into the fore as part of the cancer moonshot is something we've been talking about. So stay tuned. I hope to have some additional progress to report soon. But Ned is pretty excited, and he's getting increasingly excited about the whole concept of exposomics. And how do we get beyond one chemical at a time? Because that's the reality, is people are developing cancer from this broad base of exposure of different things in the environment. So we're working on this, and I know Gary is on here. I thank Gary for a lot of the work that he's been doing to pull together the exposomics community, along with David Delishaw and others. But so Lynn, I guess just in a nutshell, this is an area of great interest to me. I know it's an area of great interest to Ned, and so stay tuned. So hopefully we'll have some progress to report here soon.
If I
Does
could
that
add
answer your
one,
question?
yeah, I would just add one point, which I should have mentioned, and the focus on development of new therapeutics. But of course, many of those have toxicities that are important in terms of the survivorship and quality of life for people who have had cancer. And so much of the expertise, it's in NAEHS, it's in our academic community more broadly, and we need to be more engaged with that as well. Because we're anyway. Thank you so much.
Totally agree. And in fact, as you may recall, one of those 5 different leadership values that I talked about soon after becoming the director is collaboration. And I really think that it's really integrating the work, taking what we do in environmental health sciences and integrating it with the Cancer Institute and other ICs. I talked about the progress we're making with NINDS through the leadership of Cindy Lawler and their extramural division. So there are lots of exciting things that we could be doing. And the fact of the matter is that the environment is really important in the development of human disease and in the maintenance of health. So we'll continue to push that thing. Phil, I see that you have your hand up. So you're next, and welcome again to the council. It's great to have you with us.
Yeah, thanks, Rick, and thanks for a very nice presentation and a lot of progress. It's good to be back in the NIH circle again. You can probably guess my question. You skipped over it, but actually it relates to what you just said about collaboration and working across institutes. Can you just say something a little about the data program that was on your slide and how that interrelates with the Office of Data Science Strategy, with the idea of data and methods being shared and better across all of NIH?
Well, Phil, there's been a lot of work. Well, you set us up well. I mean, you brought a very powerful vision to the NIH several years ago that we got to get out of our silos. We have to start building those data platforms that allow the integration across all 27 ICs in the NIH, as well as integration of data platforms across the federal government. So we're making progress on that. And I don't know exactly where to start. In fact, maybe it would be good for the two of us to just have a briefing to update you on where we are with things. But there's just an increasing awareness that we need to be developing these collaborative data platforms. And specifically in the area of exposomics, we need to define what is the data that we collect, and how do we collect it around standardized vocabularies and ontologies. And then to catalog this in a way so that people at NHGRI who are sequencing genomes and studying the genetics and genomics of human disease can use this environmental data. So we've also been very actively discussing the importance of bringing environmental data into the All of Us program. So that is, there's a new chief medical and scientific officer, Jeff Ginsburg, who actually will be spending a third of his time on campus with us at NIEHS. So developing the data management platforms so that you can seamlessly integrate environmental data, including the near-term effort is to bring GIS, geospatial data, and integrate that into all of us. And actually something I'm personally involved with is the whole issue of sustainability of databases. So I've always, I've been, for most of my career, I've been asking someone to step up and talk about what are the sustainability parameters for all these big and expensive databases. Now I'm finding myself as the co-chair along with Mike Chang, who's the new director of NAI, to develop a comprehensive sustainability plan for large data resources. Can you hear me? Can you hear me okay? I just lost my speaker there.
Yeah, you're coming.
okay.
Okay, sorry. So there are a number of things going on. Was there a very specific pointed question you had for me that I didn't answer, or did I?
No, I mean, it's great to hear the general directions that are going on. I will reach out to you separately because, I mean, I do keep in touch with Susan Gregorick and the folks that are actually really actively continuing the work and doing a great job, in my opinion. So it would be good to see frankly, how we can help further.
Well, it's actually you're on our radar screen. So again, from my point of view, having worked with you previously when you were at the NIH, I think you set us up well, and we're I think on a great trajectory. There's just a lot of things that need to be done. They're all pretty expensive, and which includes also just building the whole, dealing with the sociology and the way that people share data. I know that my involvement in this radical acceleration of diagnostics, that program did it right. I mean, right at the outset, they developed a data collecting center, and so we're developing all the rules now around data sharing and what do you share, when can you share it. So all of that's actually happening. So a lot of moving parts, but I think we're all moving in the right direction, and we'd love to have people like you well integrated into into these various efforts.
Well, I've taken a step closer geographically. I'll be in touch.
Sounds good. Okay, terrific. Glad to hear it. Okay, Trevor Penning, it looks like you have your hand up.
Yes, I do, Rick. Really enjoyed your presentation. I wanted to build on the remarks made by Lynn as it relates to chemical carcinogens and exposures. In the recent Biden report, which talked about revamping the moonshot process, one of the big areas of interest there was increased screening for cancer. And in that report, he identified that we have this huge health disparity in terms of screening individuals, especially in individuals in environmental justice communities. And we all know there's great disparity in people of color and various forms of cancer. So I'm wondering if there's going to be some effort with NAEHS and NCI to tackle the issue of environmental justice and cancer causation.
Well, the whole issue of environmental justice, health disparities, it's not just partnership with the NCI. We're doing a lot of work with NIMHD and NICHD, a number of other institutes. So I think that the issue around environmental justice needs to be pretty broad-based. And there's a cancer component to this, but there are several different health outcomes that are associated with environmental justice. So let's see, I'm just trying to think. This is a pretty broad-based question, just like Phil's. There's a lot of work that's going on. I think with the additional money that is slated to go into NIMHD's budget, I know that Eliseo Perez-Dable has been reaching out and working to create more collaborative programs around environmental justice. Is there a very specific question that I'm missing that you're asking?
Well, I think when you go things like prostate cancer, for example, right, the morbidity and mortality associated with breast cancer is twofold greater in African Americans than in white Caucasian men. And so the issue becomes why is that? And there probably clearly is both an environmental factor, a socioeconomic factor, access to healthcare, all those things, and speaks to environmental health in the broadest sense. And so I was just wondering if there's going to be some special initiative that might be put aside for, I agree with you, there are many environmental justice issues, but this is one that's been identified by the president in his recent report. And I think it's an opportunity perhaps that could be seized upon.
No, I think it is an opportunity to be seized upon. And when I think of the exposomic framework, the exposomic framework is not just about chemicals in the environment, but also the psychosocial, the health disparities. I mean, the whole variety of different factors that have to be integrated into evaluating, environment and as it relates to cancer or other human health disparities. So whether there will be a specific focus on environmental justice coming out of the moonshot, I don't know, but I'll keep you posted as I learn more about that. How does that sound?
That sounds great.
And let me assure you that I will continue to push the issue of environmental justice. I know that several of my colleagues, I've been discussing with them. I'd like there to be more general discussion around environmental justice issues, around the broad-based issue of health disparities. When I talk with my colleagues and other IC directors across the NIH, I mean, a lot of those health outcomes are associated with the types of differential environmental exposures that are associated with health disparities. So, and those are environmental justice issues. So I'll continue to pound the pavement on that one, and I'll keep you posted as I learn more.
Great.
Other comments or questions? Pat, how are we doing on time?
You're exactly 1 minute over, so we're actually right on schedule. We're doing well.
Okay, good. Well, I'm glad that I try to make sure that there's at least some time for questions. Okay, well, I'll tell you what, then we better move on. And actually, Trevor, we are, well, just stay tuned around the whole issue of environmental justice. I think you will be very pleased with some of the speakers that we're trying to line up for the June meeting.
Great, thank you, Rick.
Okay, so Pat, I turn it back over to you. Do you want to take us on to the next agenda item?
We're ready for our NTP update. If you want to introduce Brian or.
Okay, I can just quickly introduce Brian. So Brian Berridge, who has been with the NIEHS and the Division of the National Toxicology Program for, what is it, 4 years now?
Yep, 4 years.
But who's counting? Brian has just been just a remarkable partner with me, bringing some very powerful, innovative visions to the National Toxicology Program. And over the last, about 12 months, he's been working with the BSC and the NTP to be thinking about how are the, what are the types of things we can do to bring innovation into the toxicology realm at NIEHS. So we've asked him to give an update to all of you on some of the pretty exciting things that are happening. So with that, Brian, I will turn it over to you. The virtual podium is yours.
Excellent. Thank you, Rick. And good morning, good afternoon, everybody. I am excited to have this opportunity to share some of the things that we're doing here in DNTP at NIEHS. One of the things that Rick and I share is a significant interest in innovation and leveraging our unique place in the world to be a catalyst for innovation. So I hope to share some of that with you this afternoon. So do I have control of the slides, John or Pat?
I have John. Have you got them set up?
Stand by.
Okay, thanks.
You should have control to go ahead and click
Great.
Once or twice. There you go.
Thank you, Nathan. So what I'll spend a little bit of time this afternoon talking through is a little bit about DNTP, just primarily for those of you who are new to council and reminding those of you who are not, a little bit about what we do, kind of the uniqueness of our role, both at NIH and NIEHS and more broadly than that in the community of toxicology. Our rationale, what the value proposition for innovating, recognizing that innovation is not new, even though I use the word probably more than has been used in the past, just because I'm kind of enamored by it. The innovation didn't start when Brian came to the organization. It has been deeply embedded in this organization. I'll share a little bit of that with you. A little bit about the opportunities and some of what we're doing contemporarily to build on our strong history and innovation. And then again, emphasizing where I think DNTP has a unique place and a role to play as an engine for innovation in applied toxicology. So just to start, the DNTP is an intramural division of the NAEHS within NIH that conducts applied programmatic research in toxicology. So not only is our focus in toxicology, but actually the way that we work is unique in that we're not a basic science organization. We're not a PI, principal investigator-based organization. We are a key partner in the Interagency National Toxicology Program, even though our current division name is Division of the National Toxicology Program. We don't do that by ourselves. We do that in partnership with related organizations at FDA and at NIOSH or CDC. Our mission historically has been traditionally about hazard identification and characterization with a strong influence on environmental exposures, but in fact do some work with therapeutics. Over the last couple of decades, we've gotten much more involved in developing novel tools and approaches, which are again enablers for the rest of the community. And training is also an important part of what we do. As you all recognize, applied training is not a huge strength of a lot of academic institutions that are much more oriented towards basic science. And in fact, in a day when I got into toxicologic pathology, which is what I have traditionally done for a living, it wasn't unusual to get that kind of applied training on the job, and that's harder to do. So our role in that particular area is more and more important. Apparently this thing has got a mind of its own. We also, by virtue of the fact that we do programmatic research, are also a multidisciplinary project team-based research program. So the work that we do involves folks across our organization. Again, it's not an individual PI driven research. Because of our unique place, the fact that we're not regulated, we're not a regulatory agency, we're not a commercial or an industrial organization, we have a unique role to play, I think, as an innovation incubator and an engine for the field of toxicology. And I hope to be able to demonstrate that with you as I go through this. You know, traditionally, we have had our core strength in producing monographs and reports, generally reporting out sort of traditional guideline in vivo kinds of studies around a number of different hazards, but also in more recent past, getting more literature-based kinds of assessment. But these are our traditional products and the ones that are probably best recognized. In the process of doing that, we also produce a lot of resources that, again, that are key enablers and tools for the rest of the community based on the kind of work that we do. And you see some examples here. All of the data that we generate is put into a large database, so it's all very transparent. As we think about building data science infrastructure, the work that gets done in DNTP is a pretty good foundation for building on that, just because we have a strong history in collecting and ultimately transparently sharing data. The kinds that we study, the things that we study are fairly broad. They are generally contemporary kinds of issues, but generally our research goes with where the problems are. So we're a problem solving kind of an organization. But also by virtue of the work that we do and the scientists that we have in this division, we're also a significant source of subject area expertise. And that expertise is leveraged through the vast global networks that our scientists have. Again, a lot of the work that we're best known for is conducting the kinds of studies that are the expectations of regulatory agencies. And traditionally, as you also know, these are generally animal studies. And for us, particularly on the environmental side, they're generally rodent studies. Rodent studies are also done to support drug safety assessments. And so these are very traditional products for us. We have a historical strength. Our independence in the overall scheme of things allows us to be a sort of trusted source, because we're not generally have skin in the game other than, you know, just a purveyor of quality science. So this is the kind of thing that we're traditionally known for. Again, innovation is deeply embedded in our organization. When I first got here four years ago, and we sort of reflected on what the key strengths of this organization are and have been, innovation sort of floated to the top. That was very convenient because when Rick took on his position and ultimately shared his key values that ultimately have been embraced by the organization, innovation floats to the top. And in fact, innovation has been codified in our mission statement, which is leading the transformation of toxicology through essentially innovation. So innovation is a core part of this organization. And we don't innovate just for the sake of innovation, just to do something new. And there is a strong value proposition, and that value proposition is represented by the fact that there are increasing demands on us to do the kinds of things that we do. And you probably recognize that the number of things being put into our environment is fast outpacing the usual approaches that we have used to characterize the hazards associated with those environmental exposures. There's also a significant interest in having more human relevance to the kinds of assessments that we do. We use animal studies historically because we fundamentally believe that they are representative of human relevant biology. And I think that our history of being able to use that information to protect people from unintended harms sort of bears that out. But there's also interest in greater precision. And Rick mentioned, his interest in sort of individual susceptibility, genetic susceptibility, that susceptibility associated with socioeconomic status and all those kinds of things. As a society, the better we get, the more that we expect. And part of that expectation is that we individualize our understanding of hazard. And so that requires that we kind of up our game. As a producer of data and knowledge over the last 40 plus years, we recognize that the volume of data and knowledge that is available for us to leverage is considerable and is growing exponentially. So we've got to get better at our approaches to being able to leverage that in addition to generating new data and knowledge. In society, we're a very technology-driven society, and there's an expectation that you're going to leverage that technology to ultimately improve the way that we do what we do. And so there's a good rationale for us to do that. Despite the fact that our key strength has been animal studies over time, there is a growing expectation that we reduce our dependence on animals for a variety of reasons. And as an organization, we're committed to doing that and fundamentally believe that by leveraging technology and getting better at what we do, that will allow us to decrease our dependence on animals. That said, we're still committed to using animal studies because we think they have an important place to play, not only in contemporary hazard assessment, but ultimately enabling us to invent a different future. A lot of this boils down to the need to be able to be more predictive. And what I mean by more predictive is not necessarily having to do a 2-year bioassay, for example, in rodents to actually recognize that an environmental exposure might have carcinogenic potential for it. And so a lot of what we're doing is trying to understand how to interpret shorter duration or shorter term bioactivities to give us a sense of what longer term outcomes potentially are. So one of the things that has been a key learning for me in coming into this organization, and this is basically an org chart for the DNTP, is recognizing that it's not all about the science, right? So that's my natural inclination because I'm a scientist and I kind of like to noodle around in scientific problems. But organizationally, if you're not efficient at what you do, it does not allow you to be efficient and impactful as you conduct your science. So over the last few years, we've put a lot of effort into our organizational structure and function and tried to innovate the way that we function as an organization by centralizing some functions, by putting more emphasis in upping our skills in project management, by actually articulating a strategic portfolio that is prioritized, not just having a collection of interesting things that we do, but actually recognizing the most important things that we do and putting significant effort in those areas to have impactful and timely outcomes. I mentioned the fact that we've got a long history in being transparent in sharing our data. We've built an infrastructure over time. That's an infrastructure that needs to be more and more integrated with other data repositories. And so that's a significant part of our effort. Administratively, looking at our organization and refining our business practices, again, so that we have the ability to be more efficient in how we invest our resources and conduct our science. And we've even innovated in the way that we engage our outside advisors, in particular our board of scientific counselors, and over the last couple of years have engaged them much more proactively and prospectively at a much more strategic level. And I think that has paid significant dividends in helping us to define this strategic and prioritized portfolio. But in addition to that, we've also got a great history in innovating our science. And so these are our branches, and these branches are basically the homes to our technical and subject area expertise and capabilities. And in each of these branches, we're constantly innovating and improving the way that we do our, basically conduct our science. And I think it's notable that on either end of this spectrum are two areas that I think are significant growth areas for us, both in our computational capabilities and our ability to generate high throughput mechanistic kinds of insights. And then again, leveraging the considerable data and knowledge that currently exists and that we have contributed to over the years. But even in the middle of all of that, you know, the kinds of things that we do traditionally in our systems toxicology branch, where we have done, we're the traditional home of our guideline studies, recognizing that those guideline studies might be a bit more hypothesis driven. And so having an interdependency with the kind of data that we generate in our mechanistic toxicology branch, or even in our predictive toxicology branch, where our high throughput screening and computational efforts exist. And then at the core of a lot of what we've done is our characterization of the toxicologic changes, which has traditionally been very heavily dependent on pathologists to do those kinds of characterizations. But understanding how we take that pathology to the next level and gain more mechanistic kinds of insights has been a key interest of ours. So the bottom line of all of that is that not only are we operationally innovating, but we're also innovating our science. One of the things that we've done a few years ago when I first came into the organization was to step back and reflect on the full spectrum of capabilities, technical capabilities we have in this organization. And one of the things that we recognized is that we, like a lot of organizations, a problem comes through the door, you pick a tool that you think would best address that problem, and you start working on that problem in the context of that tool. Well, the collective opportunity here was potentially something we were missing. And that collective opportunity was to actually use the full spectrum of tools that we have in deliberate and integrated ways, such that we gain better understanding of how they relate to each other as we work a problem. So what we did was, and this is sort of innovative in that our pipeline isn't straight, it's circular, and it's circular for a reason. It's intended to represent an iterative learning process that comes from us applying the tools that we have. And so this represents our portfolio of technical capabilities, which are the kinds of capabilities you would expect in an organization like ours that's focused on toxicology. But again, our intent is to use them in deliberate and integrated ways that maybe a little bit more so than we have in the past. Again, to give ourselves the opportunity for an iterative learning. But the thing I like the best about it is this bit here in the center. And that is recognizing that as we're working these problems, the ultimate species of interest here are people. And those people are incredibly variable with lots of different susceptibilities and lots of complexities. And so representing that throughout these capabilities is a key interest of ours and an opportunity for innovation. So again, as we reflect on that, what we call the translational toxicology pipeline, we see lots of opportunities to refine and improve our approaches. Everything from building more capability and efficiencies in how we leverage existing information. Toxicology historically is an observational science. We use these sort of traditional study designs to ultimately characterize hazards that would be produced in a biological system that we think is relevant. Generating early, more bioactivity kind of information in a higher throughput allows us to be more hypothesis driven. And so again, we're building that into the way that we operate. Increasing the human relevance of the kinds of biological systems that we use, recognizing the complexity of those human biological contexts that we're interested in, and trying to build that into the kinds of capabilities that we use. And even again, looking at our animal studies and recognizing the value that they've had, the confidence that they have that comes with our experience with those systems. But even recognizing that technology is allowing us to even improve the kind of information we get from those animals. And even extending to recognizing that, you know, the ultimate species of interest is humans. In fact, we could derive more information and insights into toxicology from those humans. So what I want to talk through today is a bit of a vignette of these different areas and how we're trying to leverage these different kinds of technologies and approaches that we think are opportunities for us to improve our approaches. Everything from applying artificial intelligence and machine learning capabilities, building on our history of high throughput screening and sort of complementing the breadth that we've had with depth in specific systems areas, taking computational modeling to the next level, building in more host susceptibility, vulnerability into our biological systems, even thinking about modeling human disease, which is a very unique approach for toxicology, building on our current approaches for histopathology, again, by bringing in more AI, machine learning kinds of approaches. I mentioned bringing some technology into how we do animal studies. And then again, trying to understand how we can leverage actual samples and data from people. So what I'm going to do again is provide a little bit of a vignette in things that we're doing in each of these areas. So first off, again, as you look at our pipeline, that pipeline is anchored by leveraging existing information on both ends. And so each and every problem that we take on should involve leveraging what already exists before we start generating new data, not only to inform the data that we'll generate, but make sure that we're not generating data that already exists. And then on the back end, as we put all of those pieces together, being able to inform hazard assessments in a more integrated way by bringing data from these various platforms, human, mechanistic, animal data, to inform those kinds of hazard assessments. Well, as the data has exponentially increased, that makes it more and more difficult to be efficient in how you mine that data. And so again, we're looking at developing AI and machine learning approaches to create efficiencies in how we extract information from existing knowledge and data. You know, many of you are familiar with the TOX21 effort, and TOX21 was initiated a dozen years or so ago, and it put a major focus on high throughput screening as a way of dealing with the volume problem that we have, and that volume problem being things being introduced into our environment faster than we can actually do hazard assessments on them. Coupled with, we have a significant interest in a number of key areas. We have a portfolio called our Health Effect Innovation Area Initiatives. And these are specific systems-based areas where there are some key gaps in our current capabilities. One of those is cardiovascular. That just happens to be the area that I'm interested in. It's not just about entertaining me. This actually truly is a gap in our current approaches. And so leveraging the vast amount of information that currently exists, both in the TOX21 database, but also the screening that's been done in ToxCast, Shagan Krishna, who's a postdoc at DNTP, and Nicole Kleinstreuer, who is now the acting director of NICEDM, mine these databases for bioactivities that have relevance to the cardiovascular system. And the way that we approached that was to sort of reflect on sort of a biological framework. And so as a pathologist, I'm very interested in understanding the biological context instead of just sort of looking to kind of see what happens, and take a more deliberate approach. And the deliberate approach that we've taken here is to reflect on the fact that we kind of understand, because we've characterized for decades how the cardiovascular system fails. And so we created what we call our cardiovascular failure mode matrix. And within that matrix, there's a fair understanding of the kinds of biological activities that can lead to those failures. And in fact, some of those are actually leveraged by pharma in the context of the secondary pharmacology screening that is done routinely in drug development. And so by doing that, we identified a whole portfolio of bioactivities with particular relevance to the cardiovascular system that allowed us to basically mine the ToxCast and TOX21 databases to identify specific environmental and drugs, environmental agents and drugs that have the potential to be active in the cardiovascular system. And as an example, using the visualization tool ToxPy, able to create sort of a dossier of bioactivities around individual agents. And from those bioactivities actually generate hypotheses that could be tested in our downstream, down the pipeline kinds of systems are in vitro cell-based kinds of systems. So this has given us the ability to, through this high throughput data and our fundamental understanding of the cardiovascular system, generate real hypotheses that we can be deliberate in testing as we move into these other testing platforms. So that next level of biological complexity are basically our cell-based and increasingly nearly tissue-based kinds of systems. And you know, we use a whole portfolio of 2D, traditional 2D kinds of cell-based systems that, as you all know, have added significantly to our understanding of biology and pathobiology, but there are some limitations. Primary cell systems, which are kind of the gold standards, don't actually live very long. And when you look at immortalized systems, they increasingly don't look very in vivo-like. So a game changer in this world has been iPSC technology. And so we're developing a number of systems leveraging these advances in induced pluripotential stem cells to start to model our systems in what we hope are going to be more human relevant ways. One way of bringing in more of that, not only human, but in vivo relevance, is actually thinking about in the context of more architectural kinds of systems. The 3D systems, where in fact you start to get more in vivo-like biology in those systems. And so we're also looking at three-dimensional iPSC-derived systems. A few examples of that are in the next few slides, and the first of which is some work that's been done with hepatocytes. So as you all know, that the liver is the center of the toxicology universe, and as a cardiovascular person, I've tried to sway the thinking around that, but I have to admit that in fact, the liver is a pretty doggone important organ when it relates to understanding toxicology and hazard. So that was a key area. And in fact, some work that's been done by Steve Ferguson and Srini Ramagiri in DNTP to look at three-dimensional spheroids, hepatic spheroids, and understanding how biologically they act relative to what you would expect in vivo. And in fact, have demonstrated that when you look at key biological activities like xenobiotic metabolizing enzyme expression, that in fact, when you start looking at these cells in a more three-dimensional matrix, that they're much more in vivo-like than they are if they're in a sort of a planar 2D system. And in fact, when you model those two together, then in fact, you see significant differences in that bioactivity and things like their benchmark concentrations and the kinds of activities that you see emerging from that. So by developing this, it starts to give us an opportunity, particularly when you can look at human versus animal derived system. It allows us to start to work what is called the toxicology parallelogram to start to understand how our animal-based systems relate to human-based systems. So this is a significant advance in our ability to model human and in vivo relevant biology in vitro. As I already mentioned to you, the cardiovascular system is a primary focus for us in the work that Shagan has been doing. And then lately, she's been taking some of the initial work that she did to start to develop some computational tools from that. One of the initial efforts was actually looking at bioactivity on the HERG or potassium IKR channel in the heart, which for those of you who are familiar with some of the primary issues in drug safety assessment, HERG activity, QT prolongation, proarrhythmia is a big concern in drug development, and actually starting to recognize that there are environmental agents that have similar kinds of activities. And so Shagan's been working on developing a QSAR tool for identifying structures that putatively potentially have HERG bioactivity. So we're developing a whole portfolio, again, of in vitro activity mechanistic kinds of assay systems that have specific relevance to the cardiovascular system. Part of that is actually leveraging work that's, again, already been done in pharma. And so in pharma, there's been a significant effort over the last several years to develop a more integrated approach to how drugs are evaluated for their activity on various ion channels in cardiomyocytes to try to truly get an understanding of which of those activities are likely to lead to a proarrhythmic risk in patients. And again, as we look at some of the environmental kinds of chemicals that we're interested in, you start to recognize that there are those that have activities that have proven to be worrisome in drug development, or whether they occur actually at levels of exposure that the people are likely to see as another part of that. But again, leveraging the iPSC technologies to look at cardiac relevant kinds of activities like calcium transients. Calcium is a primary mediator of contractility. Being a dynamic organ system, mitochondrial ATP production is a pretty significant part of that. And so looking at something, sorry for that. But also looking at mitochondrial activity, looking at bioenergetic reserves, something I'm going to mention here in a little bit more. Also looking at hypertrophy as a structural endpoint that is one that's characterized in vivo. You know, electrophysiology, again, relating to HERG and other ion channel kinds of activities, and even looking at things like disease modeling. And again, I'll mention something a little bit more about that a little bit later. But again, taking a more integrated approach, using iPSC technology to get a more human relevant readout of the kinds of activities that we're interested in to evaluate some of these hypotheses generated by our high throughput screening. The other organ system that we're starting to explore in these three-dimensional kind of in vitro systems is the kidney. So the kidney is another major mediator and target of toxicology as a major excretory pathway. It's also very active in xenobiotic metabolism, particularly in the proximal convoluted tubule of the renal nephron. There's a couple of areas that we're kind of interested in. PFAS chemicals have some renal transporter activity that is a contributor to their biopersistence. So that makes modeling the kidney a useful tool for us in the context of a problem that we're interested in. We're also interested in chronic kidney disease and how it might relate to environmental exposures. And there's a disease that some of you may be aware of that is has been endemic within certain regions of the world in agricultural workers. And so understanding how we can model how environmental agents might be contributing to that is of interest to us. So liver, heart, and kidney are our initial forays in the world of iPSCs and three-dimensional culture systems. In addition to that, you know, we recognize that many of our stakeholders, people in society, are walking around with very common diseases, and cardiovascular disease is a good example of that. So if you look on the left-hand panel and you look cumulatively at or collectively at disease like heart failure and stroke, cerebrovascular disease, those kinds of things, they're in fact a major contributor and the most major contributor to mortality in US and even increasingly in global societies, adding a significant healthcare burden. And so cardiovascular disease is a major part of the human context that we're interested in. And we don't traditionally look at how environmental agents can be contributing to those diseases. We look at how environmental agents might be inducing those kinds of diseases, but not how they might be contributing to their onset, progression, severity, those kinds of things. So we're putting some emphasis into trying to understand how we might model those some of those common diseases in meaningful ways to allow us to interrogate that very thing. So as an example, in a typical in vitro system, you're not going to model the complexity of coronary artery disease. But in fact, when you look at coronary artery disease and some of the sort of salient features of that disease, there are parts of this that can be modeled and in fact have been modeled and are represented in the literature. So we're looking at some of those key elements of the pathogenesis of a disease state like coronary artery disease that is very common, and trying to understand how some of the bioactivities that we have screened for might generate a hypothesis that these environmental exposures might be contributing to, again, the onset, progression, or severity of coronary artery disease. There's not a shortage in epidemiological associations between environmental exposures and things like coronary artery disease, MIs, those kinds of diseases in people. It's making the sort of mechanistic connection that's a little bit more challenging, and that would be challenging to do in our traditional systems, and why we're developing these more disease-based approaches. So in each of the areas where we're developing those novel in vitro modeling systems, we're looking at common diseases. And on the left-hand side here, in addition to looking at elements that would be associated with a common disease, like again, coronary artery disease, also recognizing that genetic or gene mutation related diseases are also represent a susceptibility for which an environmental exposure might be contributing. But then there are also disease states in the liver and the kidney that are interesting. So again, we're trying to understand how we can model some salient features of those diseases. In addition to that, we also identify and have used in the past for various reasons animal models of those disease conditions. So we have the ability to qualify the outcomes in our in vitro systems with actual in vivo experiences. And so these are two sections from the aorta and the aortic sinus of an ApoE knockout mouse, where we're recapitulating atherosclerotic lesions with features that ultimately we can measure and understand how they might be exacerbated by an exposure. Another thing, in addition to considering how environmental exposures might be contributing to existing disease, is how environmental exposures might be contributing to the susceptibility to a common disease. So an area where we're looking at that is in the context of HIV therapeutics, which is a research area that we've had ongoing for a number of years. So I think many of you may recognize that patients with HIV, most of which are being treated with antiretroviral therapies, have an increase in incidence and prevalence of cardiovascular disease. And some of that relates to having a chronic infectious disease, and some of that relates to the drugs that are used to treat those patients. Increasingly, there are in utero exposures, because as HIV drugs get used more prophylactically, so preventing the vertical transmission of the viral infection, then the pregnant mothers are being treated with what generally are combinations of HIV therapeutics, which is the way HIV therapeutics are generally used. Then you're presenting a potential risk to those in utero, the fetus or the offspring, that wouldn't necessarily be treated with the drugs post-parturition if there was not better vertical transmission. So, long story short, there is the potential that in utero exposure is causing an effect that might actually make that offspring more susceptible to, let's say, cardiovascular disease long-term. So that's actually something that we're looking at in some studies that we're doing. And the way we're looking at that is not only evaluating sort of normal structure and function in the way that we traditionally do that with histopathology and heart weights and those kinds of things, but actually looking at functional parameters. So we're looking with echocardiography, for example, for things like ejection fraction, fractional shortening, the kind of clinical endpoints that you would expect to see. But in fact, stressing those systems to understand if, in fact, whether there's potentially a subclinical effect that is preventing that system from being able to respond to challenge. And in this particular case, we're using dobutamine, which is a non-selective adrenergic agonist that increases the force of contraction. So you evaluate two potential parts of that sort of functional effect. One, the force of the contraction, and the other is the relaxation, which in fact turns out is the more ATP dependent part of that overall cycle. So by looking at a dobutamine stress, which is not unlike one of us going in and getting a treadmill test, or if it's chemically induced using adenosine, we're using a chemical stressor to elucidate subclinical effects on the cardiovascular system to recognize the potential for a longer term susceptibility to something like cardiovascular disease. Genetic susceptibility, also a keen interest in fact, traditional approaches using genetically diverse rodent models like the diversity outbred and the collaborative cross, but actually starting to look at the cells generated from those rodent models and understanding how that genetic diversity ultimately impacts the outcome of various environmental exposures, and in fact, understanding how they relate to the kinds of uncertainty factors that are typically built into those kinds of equations. One of the areas that I'm particularly interested in, because I just kind of have a bit of a translational bias to the way that I think, is understanding how well we can align to the traditional clinical context. And so, for example, if any one of us goes to see their primary care physician, there are a variety of parameters that are traditionally measured when you walk into a doctor's office, regardless of what the primary disease or complaint that you're presenting with. And the reality of it is that in our animal studies, many of those things are not traditionally captured. And so there are gaps in the kind of data that we collect in our animal studies versus the kind of data that we would traditionally collect clinically. I think a major part of being translational in the way that you do is to align the kinds of data and knowledge that you're generating from your modeling systems. And so it turns out that in fact, there's technology being developed that allow us to align our animal studies more to a typical clinical scenario. And where the major effort is in this particular area now is in the context of computer vision aided behavioral assessments, for example. But there's also a history of being able to use very sensitive biomonitoring capabilities for cardiovascular endpoints, respiratory, and those kinds of things. Many of those are fairly invasive in their current application. I think technology is going to allow us to do those in much less invasive ways, which I think is going to give us a better opportunity to be able to measure those kinds of endpoints more routinely in very sensitive ways to have better alignment to the clinical setting. Another area, histopathology is a significant anchor for the way hazard assessment is done in traditional animal studies. And so we're often in the context of, for example, this is a 2-year bioassay, and this is looking at our historical control database. So these are animals that are untreated. And what you find is that our traditional animal models have a background of disease, just like people do, including tumors. And so when you're looking for an endpoint like a change in the incidence of a particular tumor, then sometimes that can be a challenge when your background is variable. And so in an assessment that is largely dependent on human observation of pathologists, and in fact, in our approaches, there are lots of steps we put into our system to account for the bias that Brian might bring to his histopathology assessment through the application of peer review. The opportunity to take it out of the human element and use AI or machine learning to be able to validate or qualify an outcome that is based on a human observation is very appealing. And so we're looking at AI and machine learning opportunities for being able to apply that to histopathology for things like identifying tumor versus non-tumor, and even making differentiations between benign and malignant tumors, which again is an important part of our assessments. So again, this is another innovation that we're pursuing. I mentioned the fact that, again, humans are our species of most interest. And the reality of it is that, we don't do a lot of clinical trials when it comes to environmental toxicology, but in fact, there are lots of places where human samples are being collected routinely. And the DoD is one of those places where there is a massive repository of human samples that have been collected from service people over time that can be leveraged to ultimately identify biomarkers that emerge associated with certain exposures, because there's a service history for each of these service people, and also health records that ultimately are transferred over to the VA. So we have an ongoing study now to evaluate a cohort of service people or their samples to be able to look for biomarkers of neoplasia by looking for at cohorts that have developed a tumor. So this allows us to start using humans as sources of insights into exposure-related health effects. And then looking at our computational approaches, and again, we've got a lot of emphasis in developing QSAR tools and also using computational approaches to extrapolate IV-IVE kinds of relationships, but recognizing that biology is more complex than that and bringing some of that complexity into our modeling systems. And so we're just now developing some collaborations to start to apply multi-scale computational modeling to some of the problems that we're interested in. And then lastly, just to wrap up, because I know I'm at time here, is again, recognizing that DNTP has a unique place to play as an early adopter of some of these innovation opportunities that we can leverage in a very applied kind of context to help others build confidence in understanding how to apply those technologies, and even have the opportunity to influence how those technologies are developed by bringing them in and starting to use them in the context of the way they would be used in more broadly in toxicology and hazard assessment. So I won't read these words because again, I'm at time, but again, we have a history of innovation in DNTP. We've renewed and embraced our commitment to innovation. We think it's a unique role for us because of our unique place in the world, both in NIH and in applied toxicology. And we see that as a key part of our mission. So with that, I will thank you. And I don't know, maybe Pat, do we have a minute for a question?
Yeah, I think maybe we have time for one quick question.
Pressing questions. Boy, Brian, lots of things happening in the DNTP.
Indeed.
Trevor Penning, looks like you have a question. Yep. And Irva, we'll take 2 questions.
Am I first?
I'm sorry.
Okay.
I think Trevor had his hand up first, at least according to Steve. So
Okay.
Trevor, do you want to go first? And then Irva, you're next.
Trevor, you're on mute if you're talking. There he is.
Yeah, sorry. My question relates to predictive toxicology.
Yeah.
It seems to me that large drug companies have a large amount of toxicological data on chemicals that have not progressed to the clinic.
Yeah.
And if that information was to be made public, then we could get ahead of the game in terms of being able to predict the toxicology of unknowns. So is there any emphasis from NIH in general to try and get this information from the drug companies so that it can actually be poured and improve toxicological prediction?
That's a great question, Trevor. And there is not a broad-based effort in general to do that, but there are collaborations through, so the HESI organization that Rick mentioned earlier that had awarded Ken Olden an award. That is a place where government, academia, and industry get together and work on specific problems. And in those collaborative contexts, there is occasionally data shared that give you insights into those kinds of things. But that doesn't get anywhere near what the point that you're making. And in fact, it's a similar situation in EPA and the chemical industry that is also sitting on a whole lot of data that would be very, very meaningful. So it is not inconsequential to get around those barriers, but I think that's a key part of us being able to get to that future state. What we do now is probably generate data that has already been generated by somebody else in many instances, and that's not a good use of our resources. So I think we need to really push and find better mechanisms for getting access to that kind of information. But it's not an easy thing to do, but it's a great question, Trevor.
This is a quick comment, Brian. One of Francis Collins' accomplishments was really bring together the public-private partnerships with several different pharmas. And I don't know whether this topic has been part of those public-private partnerships, but I think there's a framework in place using the NIH, using different mechanisms within the NIH Foundation to possibly make those things happen. So Trevor, thanks for bringing that up.
Yep.
So I think a quick question from Irva, and then we probably better go into break.
Sure, quickly. Actually, there were several things that I can try and catch up with you offline, maybe Brian. But I was interested. This is a very interesting presentation, and especially the whole 3D testing model to really be able to expand the amount of information that you can gather and probably much, so that part I found really exciting. I was just wondering, and one of the things you mentioned at the end was the DOD repositories and that you're looking at. And I just wondered, you mentioned cancer biomarkers. I wonder whether you were looking at anything broader than that, because it looks like it's an incredible resource. And I also wonder to what extent extramural people may be able to, I don't know, access the results that, I mean, obviously the results will become public, but some of those repositories as well.
So it's a good question, Irva, and this is our initial foray in doing this. And so our initial focus is in cancer, because that's another one of our health effect innovation areas. But I agree with you. I think it has much broader opportunity beyond that. But our initial foray in that is very focused, and it'll be even a specific tumor in the work that we do.
Can I slip in just another question, which is one of our chemists analyzed some of the ash samples from some wildfires and did an exposomics analysis and published that. And there were hundreds of chemicals that, you know, he could identify, you know, with pretty strong probability, but have never been studied because they're not drugs. they're not things perhaps that have been in your standard biomass burning, you know, forest fires and things like that. And I wonder how, is there a particular way to nominate some of these and hundreds of them, you know, chemicals that might give us some insights into some of the health issues that are following our wildfires.
So there is an official nomination process,
Okay.
tool on the website, but you know, for something like that, it actually, the nomination might actually be to develop collaboratively an approach to that kind of a problem, which would fit very nicely with our focus on mixtures, complex mixtures, which, as you know, is the more common way that we're exposed. And so we have a fairly big emphasis in that space. And that's also where these higher throughput sort of bioactivity based systems are ultimately going to be absolutely necessary, because you couldn't possibly do enough animal studies to deal with that.
Absolutely.
Yeah.
Thank you. Yeah.
Thank you.
Yeah.
Brian, I think we better wind it up now so that we give everyone a time for a break. So Brian, thank you for you know, giving that outstanding presentation. So I see some claps coming in from council members. Let's see, where's Pat? Pat, I'll turn it back over to you. When do you want us back?
So Dr. Tromberg is on. I don't want to take too much of his time. So can we try to get back at maybe 2:17? How about something like that? That'll give us almost 10 minutes. That'll give us 11 minutes. How's that? 2:17. Thank you.
Great. Okay.